Hi all, and I welcome you to my YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to start with chapter Inverse Trigonometric Functions. Don't forget, I do understand that people are waiting for calculus part, but relations and functions and inverse trigonometric functions are the building block for the calculus part. Let it be differentiation or integrals. Okay, so in this lecture we are going to completely finish inverse trigonometric functions. So chapter inverse trigonometric function. In short, we'll be calling as ITF. Okay. Let us recall from the chapter relations and functions, we had one important definition, that is invertible function. Recall what was the definition for invertible function. A function, let's take it here, invertible function. Why am I talking about this? Simple. Inverse, invertible, yes, both are related. So a function f from a to b is said to be invertible if there exists a function g from b to a such that g composition f should be identity function and f composition g should also be identity function, and here we should write the domain of the rightmost function. So here the rightmost function is f, domain is a, so write down a, and here the rightmost function is g, so what's the domain of g? B, so write down b. And don't forget, g is inverse of f, and f power minus 1 is not equal to 1 by f. This is only taking the element from codomain to domain, or I can say range to domain. So for this we also discussed that if a function is invertible, then the function f should be, let us write properly, the function f should be bijective. Only then inverse possible. When I say bijective, it means it should be both 1 1 and on 2. So having this background, let us come to this chapter. Our entire chapter is going to go with this. The only difference is, no, when you're talking about the chapter relations and functions, we have just got f is a function from a to b. F can be any function, any general function. But as soon as I come to inverse trigonometric function, my function f becomes a particular function. It is going to be a trigonometric function. On that we have to talk about inverse, nothing but it should be bijective. Now if I talk about the first trigonometric function, sin x, y equal to sin x, whether this is a bijective function, nothing but 1 1 and on 2. To understand this graphically, I would like you to understand graphically. So before I go to this now, let I give you graphical approach how to know whether the given graph is a function, first point. Second point is, as soon I know that the given graph is a function, how to know it is 1 1 function as well as on 2 function. Then we can go ahead with the graph. I think that will be ideal for you. So let us move ahead with that. Okay, all of you see this graph which I am going to take. Okay, one graph I will take. Just some arbitrary graph I have taken, and this graph equation, let us suppose y equal to f of x. Now whether this graph is a function or not, I have to check. Okay, now how to check? First recall the definition of a function. Our definition of function is what? It is a special type of relation where every element have one image, only one image, or I can say unique image. For this, graphically what we are going to do is draw a vertical line. What is vertical line? Any line perpendicular to x-axis or parallel to y-axis. So if I draw a perpendicular line, you can see here, and we have to talk about how many point of intersection. Here we have only one point of intersection. Here also only one point of intersection, as you can see here. But you see here, we have more than one point of intersection here. So now let us take this x values as x1, this as x2, and this as x3. So wherever it is intersecting, let us suppose the corresponding value of x1 is here, y1. Then the corresponding value here is y2. I'm just giving same subscript. It will be easy for our identification. Whereas here you see, for this the corresponding value will be y3, and here the corresponding value will be y4. Now here we have only one point of intersection, but here we have 2 points of intersection. Let us try to draw the arrow diagram of this, then things will be very clear. So you know that always my first set is A and second set is B, and coming to coordinate system, set A, the first set A will have x value and second set B will have y values. My x values are here x1, x2, x3. Okay, x1, x2, x3. Coming to y values, we have 4 y values which we are interested. We have many actually, both for x and y, but I have restricted to only these values. Okay. Now see carefully what is happening. If I just take the coordinates here x1, and when I go here it is y1. So this coordinate is x1 comma y1. Nothing but x1 is having an image y1. Okay, x1 is having an image y1. Is it a function for x1? X1 has only one image. It obeys the condition for function, definition of function. Okay, now come to x2. Here is a point of intersection, and it is having x2, and here you can see y2. So this coordinate will be x2 comma y2, x2 comma y2. So yeah, x2 is going to y2, having only one image. Next, see here, this is y3, so this coordinate is x3 comma y3, and this one is x3 comma y4. So x3 is been having image, x3 has image y3 and y4. x3 has an image y3 as well as y4. Now you see, x3 has got 2 images, and as per function definition, every element should have one image. x3 is violating the condition. It has got more than one image. Therefore, this graph is not a function. Therefore, this graph is not a function. Not a function. Let us have a space here. Not a function. So, graphically, how to commence a function? I repeat, listen carefully. For a given graph, draw a vertical line, and at any part of the graph, I repeat, at any part of the graph, if you have got more than one point of intersection, if you have more than one point of intersection at any part of the graph, then the given graph is not a function. Then the given graph is not a function. If you see from here till here, just before this part, wherever you draw, you have only one point of intersection. So till here it obeys the definition of function. But after this, you can see there is more than one point of intersection. So let's comment that graphically, how to say it is a function. So if a given graph has more than one point of intersection between the given graph and a vertical line What is vertical line? Definition: any line perpendicular to x-axis. As you can see here, it is perpendicular or parallel to y-axis. Both are correct. Or parallel to Which axis? Y axis. Here also I can have small x, no problem. So if a given graph has more than one point of intersection between the given graph, let us suppose the given graph is y equal to f of x. The given graph is here, let us write y is equal to f of x and a vertical line more than one point of intersection between this and vertical line, then the given graph is not a function. So if at all it should be a function, at each and every part of the graph, when I draw a vertical line, you should have only one point of intersection. So you just see this. So this is not a function. Okay, we wrote already. Now you see one more graph. And the graph need not be in first quadrant or second quadrant, it can be in any. Now you just see this graph. Wherever you draw vertical line, you are going to have for this graph whose equation, let us suppose y equal to f of x, you will have only one point of intersection. You can draw wherever you want to draw. See, you draw here, you draw here, you draw here, but the line should be vertical line. We have only one point of intersection at each and every point of intersection. Therefore, it is a function. Y equal to f of x is a function. Okay. Now, first make a note of this. We will talk about how to identify if it's a function, how to identify it is one function. And whatever I just discussed now, this concept we call vertical line test that I just mentioned. So, vertical line test. So, what is vertical line test? It is a test to determine function or not a function. Whether it's a function or not a function, to determine that we are going to go for vertical line test. Okay, even what I gave here, which I have erased. Now coming to how to identify whether a given function graph is one function. For this, to identify, we are going to talk about a concept, horizontal line test. Horizontal line test. Now, what is this? Let us first see. As soon as I talk about types of function, first the given graph should be a function. Logic is like this. For example, someone comes to me and asks, which subject teacher you are? For me to answer this question, first I should be under profession of teaching. Then I can say that I am a so and so subject teacher. I handle so and so subject. But if someone comes to me and asks, for example, let us suppose in doctoring field, etc., you are specialist in what? Brain, heart, kidney, which one? I will say it's not my profession. I'm not a doctor. This doctor is doctor of philosophy. I have got no Dr. Naseer Ahmed. It is doctor of philosophy. It's not MBBS doctor. It's not a medical doctor. So as soon as I justify this, the person who's asking me should stop questioning about which is your specialty, whether eye specialist or heart, etc. But again, if the person, no, I don't want to know whether you're a medical doctor or not. I want to know which is your specialty, whether heart surgeon or eye specialist, etc. Then that person we cannot speak. Why? First, to be a specialist, first I should be a medical doctor. Similarly, coming to function, first it should be a function, then comes types of function, all the 5 which we have discussed in relations and functions chapter. Now here also, I am talking about one function. To apply one function, first you have to make sure the given graph is a function. Now here, when I am taking the diagram here, see carefully, I am making sure that the graph which I am taking should be a function first of all. If you draw a vertical line, you will have only one point of intersection between the vertical line and the given graph. Let us suppose the given graph is y is equal to f of x. Again, always you take y equal to f of x, which says I am writing y in terms of x or a constant. It's a one variable, independent, and y is a dependent variable. X is independent and Y is dependent. Now, coming to 1 function. Again, here no, we draw a horizontal line. Now, when I draw a horizontal line, just see. I've drawn here. Okay. Let us suppose I'll draw one more here. See how many points of intersection. Here we have 1 point. Let us suppose the corresponding X value for this is X1 here, and for that corresponding Y value is Y1. So this coordinate will be X1 comma Y1. Let us take the help of arrow diagram. This is actually very helpful to understand. So X1 is having an image Y1. Okay. Now again we have a point of intersection. So here X2. Okay. And here let us suppose the corresponding Y value I will take as Y2. So this coordinate will become X2 comma Y2. X2 comma Y2. So X2 is having an image Y2. Yeah, it is a function. You can see it is having different images. Now come here. This is, let us say, X3, but this already named Y2. So this particular point will be X3 comma Y2. So X3 is mapping or having an image with which element? Y2. X3, Y2. Oh, this is not 1 function because X3 and X2 and X3 have got the same image. Again, here also one more point of intersection. See here, let us suppose this point is X4 and the corresponding Y value is already named as Y1. So here we are going to have X4 comma Y1. So X4 is having the image Y1. So very clearly you see that X1, X2. Okay, just see here. X2 and X3 have got the same image Y2. X1 and X4 is having the same image Y1. Therefore, this is, I can say, yeah, F is a function, but not 1 function. So from the graph, what we can say? For a function to be 1 function, if I draw a horizontal line, what is horizontal line? Any line perpendicular to y-axis or parallel to x-axis should not have more than one point of intersection between the graph and the horizontal line, not even at a single part of the graph. And if we have more than 1 point of intersection, the way we have here, 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 then it is not 1 function. Okay, let us try to code that. So horizontal line test says if there is more than 1 point of intersection between the given graph y is equal to f of x and the horizontal line. Now what is this horizontal line? Definition is any line see this line is parallel to x-axis or perpendicular to y-axis. Any line parallel to x-axis or perpendicular to y-axis. Any line parallel to x-axis or perpendicular to y-axis is known as horizontal line. So let's read again. If there is more than 1 point of intersection between the given graph and the horizontal line at any part of the graph, then the graph y equal to f of x is not what? 1 function. Now, having commented this, dear students, having understood vertical line test for checking whether a given graph is function or not, and then horizontal test to check about one function. Now let us move on to the graph of sine. See, trigonometric function. Yeah, first PUC also we have, but one additional one term is added before it. That is inverse. Nothing but invertible trigonometric function. Inverse trigonometric function. Now let us talk about y is equal to sine x, the first trigonometric function graph. If we remember the graph of this in first PUC, see carefully. The graph of sine x goes like this. Let us have here also. Yeah. Now this graph, is it a function? Yeah. Draw a vertical line wherever you want to draw. We have how many points of intersection? Only one point of intersection. You can just see. See, the chapter name itself is trigonometric function. The word function is there. So surely all 6 trigonometric ratios, sine, cos, tan, cosecant, secant and cot, all are functions. You can just see the vertical line. Now I want to verify about one function. When I draw a horizontal line, you see carefully, we have more than one point of intersection. I'm not specifying how many. I'm just using the word more than one. Because if it is more than one point of intersection between the horizontal line and the given graph, it's not a one function. So as soon I came to know more than one point of intersection, I'm nowhere interested to know how many points. But if I want to talk about how many points of intersection, don't forget the sine graph will move on like this. Is a periodic function. Periodic means it is going to repeat its value after certain interval of time. For example, here again the value will repeat. The same graph will be there after 2 pi from here to here. Okay, so it is going to have infinitely many point of intersection. Therefore, sine x is not one function. But then how come it's coming under invertible? Okay, let us try to understand. And one more thing, usually we have a habit of writing function from A to B. So here this function is actually sine is a function from A, domain is R, to codomain R. So in place of usually writing F, now we have got a particular trigonometric function. I'll be discussing only for sine. The same thing follows for the other 5 trigonometric function. Okay. Now I want to make it invertible. How to make it invertible? What am I going to do is I'm going to take a branch of trigonometric function sine x for which it will be one function. See carefully here. If I take only this part of the graph, see carefully. Only this part of the graph, this part. And I'm going to remove the remaining branch. And this is at 90, sine 90 is 1. And sine of minus 90 is minus 1. So if I take only this part of the graph, it will be one function. Let us take that one here. Graph 2. Y is equal to sine x. I am restricting the graph. And the graph is restricted from minus 90 to plus 90. And whatever the graph I have got, let us have a practice of this. Now let us draw. Yes, this sine 90 is 1 and sine of minus 90 is minus 1. Now draw horizontal line, only one point of intersection. So only for this branch, it is what? 1. Sir, one question will come. Sir, what about this part of the branch? Let us take some other color to have. Yeah. Just have some other color. Sir, what about this part of the graph? Yes, for this part, this is pi by 2 and this will be 3 pi by 2. For this also, for this part of the graph, for this part of the branch, it is again one function. But as a convention, we are taking near to origin because drawing is easier. That's what, no? Now, see this. Now, this function is defined from where to where. What is my domain and codomain? See carefully. For this, Sine is a function. See, this graph is only present between minus 90 to plus 90. So minus pi by 2 to plus pi by 2 closed interval 2. Now this time I will not give r. If I give r, it will, for this, it will be 1 1, but not onto. For onto, range and codomain should be equal. So in place of codomain, I will write what? Range. Range, how to know? See y-axis up to where the graph is present. The graph is starting from minus 1, okay, minus 1 till plus 1. So the range, I will write it here, minus 1 to plus 1. So for this restricted domain, my function sine x will be invertible. For it to be invertible, it should be bijective, nothing but 1 1 and onto. Now it is 1 1 also and onto also. I hope the logic is clear. Even though 6 trigonometric functions are not bijective, how come it is coming under the heading invertible, nothing but inverse trigonometric function? This is the reason that we are restricting the domain to such an extent that it will be invertible. Similarly, you can take this part also, okay, but as a standard near the origin is easy to draw. That's what I think the reason behind. Now comes invertible. See carefully. Just see this definition. If f is a function from a to b, then to say it is invertible, there exists a function g from b to a. Correct? No? So domain of f becomes codomain, and codomain of f becomes domain for g. And what is actually g? F inverse. Correct? No? So for this also, we will be having from this line, we will be having sine inverse is a function from, this is codomain, minus 1 to 1 to domain. What is the domain? Minus pi by 2 to plus pi by 2. Okay. So for this, it will be what? Bijective. Now understand here. First, let us try to draw the graph of this. The graph of this will be, it looks like tan and x cube graph, but it is not so. It is restricted that sine inverse of 1 will be pi by 2 and sine inverse of minus 1 is minus pi by 2. It's not going beyond. Okay. Now one more thing to be understood. Input of all 6 trigonometric function is an angle, whereas the output is a number. Whereas coming to second PUC, inverse trigonometric function, input is a number and output is a angle. And pi by 2 radian, when I say, it is 90 degree. Now let us try to understand this, and same thing is going to follow for the remaining 6. See carefully. What I mean to say is, what is sine 30 degree? It is 1 by 2. This is your first PUC. Sine function is given, operate on angle, value is one, values we are getting. Now it's going like this. See carefully. Sine is there. Sine is taking 30 degree or pi by 6 radian. Both are same, no? Pi by 6 radian is mapped to half. Sine 30 degrees half. Then I have to come back also. So sine inverse. Be careful. This sine inverse is not equal to 1 by sine, which is equal to cosecant. No, they are not same. Cosecant is reciprocal of sine. Sine inverse is invert or inverse of trigonometric function sine. Okay, I hope this point is clear. And it is. Now, see this what's happening here. Sine inverse. This is taking half and bringing back to the angle. So, sine inverse of half is how much? 30 degree or pi by 6 radian. Don't forget, pi radian is 180 degree. So, this is happening for all the 6 trigonometric function. Okay. Now, having this knowledge, let us try to have the principal values for all the 6 trigonometric function, and then we'll have a question from model question paper. Okay. Make a note of this. Dear students, having understood the concept, I thought let us try to draw the graph of all the 6 ITF, and then let us have a table on domain and its principal values. Okay. So as already we have seen this. So here it is 1 and here it is minus 1 and this is pi by 2 and this is minus pi by 2. Coming to the second graph, and this is here x, yeah, y equal to cos inverse of x. How the graph looks like. Ready? So let us have coordinate axis. This will also be helpful for competitive, and let us try to learn in detail properly. So see, this cos inverse graph is this, and here it is pi. Sorry, I mean to say this is minus 1, 0 and 1, and this there is a pi here. Cos inverse of minus 1 is pi, and there is here pi by 2, the y value. Let us write a bit more bigger. Yeah, y axis, and here it is pi value. Okay, this is about cos inverse graph. Now let us move on to next. Y equal to tan inverse. How the graph of tan inverse x looks like. The graph of tan inverse x. So it is between. This dotted line means value not taken. Don't forget tan 90 and tan of minus 90 degree, both are undefined. So this will be actually pi by 2 radian, and this point on y means value of y will be minus pi by 2, and the graph of tan inverse will be this. This is your graph of tan inverse x. Next, let us try to take the fourth one, y equal to cot inverse x. Here it is pi. Okay, and cot 0 and cot pi both are undefined, so dotted line here, and there is a dotted line here also, but it is overlapping with the x-axis. And pi by 2, cot 90 is 0. So the graph of this is this, going to be this one. Okay, let us move on to next. Y equal to cosecant inverse x. Let us take coordinate axis. Okay, so this all a number line, so I can say 1, 2 here, minus 1, minus 2. It is true for all the numbers. But here again 1, and here minus 1, and this is pi by 2 here, and here minus pi by 2, minus is here. So with this, is it visible? Yeah. So now let us go ahead. The graph will be like this. The graph goes here. So it is actually a decreasing function. Now let us move on to the last one, that is y equal to secant inverse x. The graph of this will be, let us have the coordinates x and y, coordinate axis. Now you see carefully, this is undefined at cos 90 0. So secant 90 is undefined. So here at pi by 2 it is undefined. So I'll do one thing. Let I take y x-axis bit more below. Yes. So that now the graph is covered properly. So here somewhere pi by 2, and here it is pi, and here we are having 1, and here minus 1, and here we having a dotted lines. Dotted line says the value is not defined at this point, pi by 2. That's what we can see here also. Okay, and here also the dotted line is x-axis. Okay, now let us see this. So the graph will go like this. At see, secant of 90 is undefined, so you can see a dotted line starts from here, but secant of -1 is pi. So that's what I'm trying to relate between trigonometric and inverse trigonometric function. And again here, and it's going to start like this and stop. Let us draw a bit more. Good. Yes. And here the dotted line comes and it's going to stop. It will never touch because the value is not attained. So this is about all the ITF. Kindly make a note of this. So this is the origin. Oh yes, and I hope this graph is looking good one, just a smooth graph that I draw. Okay, fine. Now for all this, let us try to discuss domain and range. Let us take it here. See, don't forget domain and range for 1 mark you are having, and even CET also direct questions you are getting. Okay, we have got like that. So here I am talking about inverse trigonometric function. Then here I am talking about the domain, and then I am talking here about range. The other name for range will be principal values. Principal values or range. Principal values or range. Let us take one by one all the values here. Okay, ready? First one is sine inverse x. So we have to see for domain x-axis up to where the graph is present. The graph is present from -1 to 0. So the domain is closed interval -1 to 1. And coming to range or principal value, see y-axis, the graph is starting at -pi/2, ending at +pi/2. So the range is closed interval -90 degree to +90 degree. First part done. See cos inverse, its graph is starting from -1, ending at +1. So domain is for cos inverse, the domain is -1 to 1, and coming to the range, it is, see this y-axis, it's starting from here 0 and it goes, see all this value, the graph is there, and at pi it's stopping. So range is closed interval 0 to pi. Next here we have tan inverse. Graph of tan inverse. See, coming to domain, all the values of x is taken by the graph. So domain is R. Coming to range, -pi/2 to +pi/2, the graph is present along y-axis, but not taking -pi/2, +pi/2. So open interval -90 degree to +90 degree. Coming to next is cot inverse. See carefully. Coming to this, see again x-axis, yeah, all the values are taken. So domain will be R. Coming to which one? Range. See y-axis. There is no graph below x-axis, but above x-axis till pi the graph is there. Dotted line is there at pi as well as on which axis? X-axis. So don't forget equation of x-axis, y is equal to 0. So 0 and pi is not taken. So the range will be open interval 0 to pi. Okay, now come to cosecant. Coming to cosecant inverse. See the domain. It is starting from -infinity to -1 and +1. See, for all these x value graph is present, but between -1 to 1 there is no graph. Again from 1 to infinity the graph is present. So the domain will be -infinity -1 union 1 to infinity. Okay, this will be the domain. But other way of writing will be from R, this entire real number, remove this point. Which one? Open interval -1 to 1, because only that is not taken. Cosecant inverse is defined from -1 and +1, so we are not including -1 and +1 to be removed. Okay. Now coming to the range, see the range carefully. It is starting from -pi/2 to +pi/2, but 0 is not taken into consideration. So the range, I will just write it here. The range of this will be closed interval minus 92 plus 90. In that, remove what? 0. Okay. Now, next one. Let's have some space here. Secant inverse. I want secant inverse domain. Come here. See, for all these x value, graph is present. Nothing but minus infinity to minus 1. This is minus 1. Graph is present. Union. Again, from 1 to infinity, graph is present. Same the case what we had here. And again, on the same reason, between minus 1 to 1, graph is not taken. So I can say from R, remove minus 1 comma plus 1. Okay. Next comes what? Range. Range is along y-axis. So 0, 3, below 0, nothing but below x-axis, there is no graph. From 0 to pi, yeah, graph is there. For all this y value, graph is present. At pi by 2, it is undefined. Pi by 2 to pi, graph is present. So the range will be closed interval 0 to pi. In that, remove pi by 2. Okay. So this is about principal value. I could have given directly, but I thought let you understand. Okay. It will be lifetime to remember, at least for second PUC and first PUC. Okay. Make a note. Now on this, we are going to have model question paper problems. Dear students, after discussing the domain, principal value, range. See, other name for principal values will be range. So you should know both the names. And on this, we have got 1 marker question from model question paper number 2. As you are aware, these are from KSEAB. Okay. Now let us go ahead. And of the academic year 2025 to 2026. Now from part A, 1 marker question. Question says match column 1 with column 2. Column 1 is given, column 2 is given. Choose the correct answer from the option given below. Okay, fine. So we have to match. If you see, here they are talking about inverse trigonometric function and their corresponding values. Here they are asking domain of secant inverse. What is domain of secant inverse? It is this. See, because of MCQ only, no, I gave both the ways of writing. Okay. So domain of secant inverse is exactly first option only. R minus of minus 1 comma 1. Then range of cosecant inverse. Cosecant inverse is here. Range is here. Minus pi by 2 to plus pi by 2 close interval excluding 0. That is here. Then range of cot inverse. Cot inverse range 0 to pi open interval. So the answer is actually, for this it is 1. For this it is 3. And for this it is 2. So 1, 3, 2. 1, 3, 2. Option C is correct. So for second question, option C is correct. This was completely on the table. Okay. Table value you should remember. Okay. Make a note. Dear students, let us move on to the next problem. This is from model question paper number 3 and part A. Question number 2. As you know, it is a 1 marker question. The principal value branch of secant inverse x. Principal value, nothing but the range. Secant inverse, it's here. It is closed interval 0 to pi and 90 degree is not taken. Closed interval 0 to pi and 90 degree not taken. It is option D. Be careful. If you forget the concept of interval, gone. Open interval means value not taken. Secant 0 is 1. Secant pi is minus 1. Both are defined. Only at 90 is not defined because cos 90 is 0. Secant 90 is undefined. Okay. So option D. So you have to be very careful. Aram so you can get 1 mark from this. Okay. I hope this is clear. Dear student, before going to the next set of problem, since there are some numerical problem, I mean to say inside ITF we have got some number. So standard angle table is now mandatory. So let us try to recall all those. Then we will take ahead with the problem. So let us have the angle here, then sine here, cos, tan, cosecant, secant and cot. And here the angle is 0 degree or 0 radian, both will give you same. Then 30 degree is same as pi by 6 radian 45 degree is same as pi by 4 radian, then 60 degree is same as pi by 3 radian, and 90 degree is same as pi by 2 radian. So here the values are 0, then 1 by 2, 1 by root 2, root 3 by 2, then 1. Then for cos it is reverse order. So start from right to left. So 0, root 3 by 2, then 1 by root 2, half, then 0, then tan, ratio of sin and cos, 0 by 1 will be 0. Here half will get cancelled. I will get 1 by root 3, 1 by root 2, 1 by root 2 will be 1, and half will get cancelled here. So I will get root 3, 1 by 0. What is 1 by 0? It is undefined. Denominator should never be equal to 0, undefined. Then cosecant is reciprocal of sine. So 0 is same as 0 by 1. What is reciprocal of 0 by 1? 1 by 0, which is undefined. Reciprocal of half is 2. Reciprocal of 1 by root 2 is root 2. Reciprocal of root 3 by 2 is 2 by root 3. Reciprocal of 1 is 1 itself. Coming to secant. Reciprocal of secant is reciprocal of cos. So this will be 1. Then this will be 2 by root 3. Then it is root 2. Then reciprocal of half is 2. And again for 0 it is reciprocal will be 1 by 0. Nothing but undefined. Lastly for cot. Reciprocal of tan, 0 is same as 0 by 1. Reciprocal will be 1 by 0, nothing but undefined. Then reciprocal of 1 by root 3 is root 3. Then 1 remains 1. Then root 3 will be 1 by root 3, the reciprocal. And here you should understand reciprocal of undefined, 1 by huge quantity will be 0. So this value you should remember, and from here we can think of solving 1 marker question. Okay, so make sure remember this will also be required as in how we go for entrance class. Okay, kindly make a note of this. Dear students, having understood this, let us take some problem. Before I go to this part B model question paper number 1 for 2 marks, let us try to take some basic problems. And here some will be assignment and some you are going to solve. Some I am going to solve and some will be assignment. First you see all these what are given, no, all are positive. So how are we going to take? For example, cos inverse of root 3 by 2. Nothing but I want that angle for which cos is giving root 3 by 2 as the number. So go to cos and search for root 3 by 2. Where is root 3 by 2? Here. So which angle is giving that? Pi by 6. So the answer for this is pi by 6 radian or 30 degree. Both are same. Like this we can go for this assignment. But now the problem is, this is assignment. But now the problem is, what about negative? All are positive here. So let me give us a note for you. How are we going to tackle negative? For sine inverse of minus x, it is minus will come out. We are not giving any result of this, the proof. It was in the old syllabus. Now it is only the results. So I am giving for all negative. So whenever I have got negative here, for tan inverse also, you can just think as negative have come out. Then we have got the third result, cosecant inverse of minus x is minus cosecant inverse x. So as you apply this, you can see the number which was negative becomes what? Positive. Similarly, cos inverse of minus x is pi minus cos inverse x. Fifth one, secant inverse of minus x is pi minus secant inverse x. Lastly, cot inverse of minus x is pi minus cot inverse x. What about the x value? It is same as the domain value which we had in the table here. Okay. Now see carefully. For example, I want the value of this. First we take this. Sine inverse of minus half. So come here. Sine inverse of minus x is minus sine inverse x. So first take out negative out. We have taken negative out. Now sine inverse of half, sine, search for half, yeah, half, and which angle? Pi by 6. So minus as it is written, and what's the angle? Pi by 6. Job done. Okay, so on that behalf you can take this as an assignment. Assignment is mandatory, dear student. Now come to cos inverse minus half. Cos inverse of minus x is pi minus cos inverse x. So this is pi minus cos inverse of half. So pi minus, which angle of cos is giving half? Cos half is here, pi by 3. So pi by 3. Now simplify, take the LCM. There is nothing yet, means 1. LCM of 1 and 3 is what? 3. 3 by 1 will be 3. So 3 pi minus 3 by 3 will get cancelled, pi. What is 3 pi minus pi? 2 pi by 3. This is the value. Okay. Now let us go to the actual problem. I thought first, before going to that problem, let us have basic. Now here what is happening? Here we are having 1, 2, 3, totally 3 functions. Composition of function we discussed in chapter functions. So we are having inverse, then direct trigonometric function, and then inverse trigonometric function. Don't forget, from school days we have a habit of solving the problem from innermost bracket to out. So the innermost bracket term is this. So solution begins. This is from model question paper number 1, part B. It's a 2-marker question. Tan inverse of 2 times of cos of 2 times of sine inverse of half. Which angle under sine gives half? Half is here. Which angle? Pi by 6. So in place of only this, only in place of this, pi by 6 is written. And be careful, it's a product of 2 terms. So I wrote multiplication sign. So now simplify. 2 ones are 2, 3s are. So what is the meaning now? Tan inverse of 2 times of cos pi by 3. So tan inverse of 2 times of cos pi by 3, cos 60, and cos pi by 3, 60. What is cos 60? Half. So write down in place of this, again into here, there is no sign, means multiplication, and this value is half. Now simplify. 2 ones are 2 ones are 2 and 2 will get cancelled. So tan inverse of 1 into 1, 1. Which angle will give under tan? 1. Come to tan, search for 1. Yeah, 1. Which angle? Pi by 4. Job done. Okay, that's it. Let us give some assignment on this. Dear students, I have given some more assignment, and surely using this property you can get the solution. So make sure do the assignment. Okay, make a note. Dear students, having understood, let us move on to this problem. Okay, we have understood this how to solve, and now just see model question paper number 1, part A, 1-marker question. Question says, if sine inverse of x is equal to theta, the principal value branch of sine inverse where this x whichever is given is lying between close interval 0 to 1, then the range in which theta lies is. Because of this itself I discussed the graph in detail. Now you see, they have not just asked principal value of sine inverse, they have said in the principal value branch where x is between 0 to 1, that range they want solution. See, they have given that x lies between 0 to 1 and they want range, nothing but output, sine inverse x value. Now throughout I have to take sine inverse, but when I take, I should know whether IT of which of the functions are increasing and decreasing. If you just see the graph of sine inverse, the graph of sine inverse is this, which is increasing function. So let I just make an attempt. If you see all the graph, no, you will see all C's, nothing but cos inverse, cot inverse, cosecant inverse, all are decreasing, and remaining sine inverse, tan inverse, and secant inverse, they are increasing. So how to remember? Very simple. After C in English alphabet, which come next? D. So all C's are decreasing. All C's are decreasing. As soon all C's are decreasing, I mean to say cos inverse, cot inverse, cosecant inverse, remaining all are what? Increasing. Simple. Now, why this is important? Whenever you take increasing function, inequality will remain same. For decreasing function, inequality will reverse. Okay. Now, since I want sine inverse, since sine inverse is an increasing function, as sine inverse is which function? Increasing. In detail about this, when I take application of derivative, there I will discuss. Okay. So only what you have remembered, for increasing function, inequality will not change. For decreasing function, inequality will reverse. Reverse means less or equal change to greater equal to. Okay. Similarly, greater equal to will change to less or equal to. So take sine inverse throughout here. Sine inverse of 0 less or equal to sine inverse of x less or equal to sine inverse of 1. What is sine inverse of 0? Come on, come here. Which angle of sine will give 0? 0. Which angle? 0 degree or 0 radian. Both are the same. So 0 less or equal to sine inverse x. Which angle of sine will give 1? Which angle of sine will give 1? Pi by 2. So the principal value of sine inverse x is close interval 0 to pi by 2. Other way of writing this is how? Sine inverse of x belongs to close interval 0 comma pi by 2. 0 comma pi by 2 is there in option B. So option B is correct. Okay. As an assignment, you can think of taking the same problem. What if the value of x is between -1 to 1? This is your assignment. Okay. I would like to see in chat box your answers. Okay. Make a note. Dear students, I just thought let us take one more problem on this. And this question is not from the model paper. Sine inverse of x, which we just completed, is from the model paper, which I have already mentioned. Now, if cos inverse of x is equal to theta, the principal value branch of cos inverse x lying in this, then the range in which theta lies. So, as I said, all C's are decreasing. So, here they have given, I have taken the question to be again the same 0 to 1, close interval. Now, since I have got cos inverse here, I have to bring cos inverse here. So, when I take cos inverse throughout, don't forget cos inverse of x is which function? Decreasing function. All C are decreasing. This is option B. Okay, decreasing function. So, for decreasing function, what should happen? As soon as I take cos inverse, this interval should get reversed. See this carefully. Cos inverse of 0 greater or equal to cos inverse of x greater or equal to cos inverse of 1. Now come to the table. Which angle of cos will give 0? Pi by 2. Greater or equal to cos inverse of x as it is greater or equal to cos inverse of 1. Which angle of cos will give 1? 0. Now this is same as something like 5 is more than 3 more than 2, which is same as 2 is less than 3 less than 5. If I just rewrite, the inequality will reverse. So here also, if I start with 0, 0 is less or equal to cos inverse x less or equal to pi by 2, or I can say that cos inverse of x belongs to close interval 0 to pi by 2. Again, it is option B only for this problem as well. And you understand here, as soon as I've taken cos inverse, inequality got changed. Let us suppose you forget to change. Let us suppose you forget to reverse. Then what will happen? Just see. If you retain same, no, you will come to know yourself that you have did a mistake. How? See this carefully. If you own change by chance you own change, in place of this you retain the same. Then you see carefully. Can it happen that 90 is 90 degrees less than 0? No. So surely you have did some mistake. And here also, no, when it is greater or equal to, again, 0 is more than 90 degree? Possible? No. So surely you have did the error of not changing the or not reversing the inequality. So again, cos inverse, cot inverse, cosecant inverse, all C's are decreasing, and remaining sin inverse, tan inverse and secant inverse are increasing function. For increasing, inequality will not change. For decreasing, inequality will reverse. Okay, fine. We can think of solving the assignment on this same ASG, but here the interval is -1 less or equal to x to 0. Okay, so make a note of this. Okay, dear students, before we go ahead for the next, we have one more 2-marker question on this tan angle table. And here we are going to use first PUC allied angle concept. Let us recall, okay, before we go ahead, allied angle concept. See, when I talk about allied angle, whenever the angle is beyond 0 to 90 degree, we need that concept. So let us recall that. So coming to allied angles. See, whatever the huge angle is there, I mean to say beyond 90 degree, we can always express that one as n pi by 2 plus or minus theta. So here there are two cases. Let us suppose n is odd. If n is odd, then what will happen? This n is integer here. If n is odd, what will happen is that trigonometric function will change to its co-ratio. Sine will change to cosine. Cosine will change to sine. Similarly, tan will change to cot, and cot will change to tan. Secant will change to cosecant, and cosecant will change to secant. I just use the word co-ratio. As you can see, just by adding CO before sine, you will get cosine. Add CO before tan, you will get cotangent. Add CO before secant, cosecant. Similarly, remove CO from here, you will get sine, then tan, and then secant. This we call co-ratios. Just by adding or removing CO, we get the other trigonometric function. This we call co-ratios. Whereas if n is even, then trigonometric function remains the same. Then trigonometric function here also. Then trigonometric function remains same. But what about the quadrant? Very simple, depends on n. Okay. Now recall for that ASTC rule also. A, S, T, C. A stand for, in the first quadrant, all the 6 trigonometric functions are positive. Second quadrant, sine and cosecant are positive, remaining 4 are negative. Third quadrant, tan and cot are positive, remaining 4 are negative. Fourth quadrant, cos and secant are positive, remaining 4 are negative. So in the first quadrant, the angle is between 90. Okay, I will just give the range. Let us make some space. Yeah, I'll let it here. Okay, see carefully. This is best. So here the angle is going to lie between 0 to 90 degree. Here the angle is going to lie between 90 degree to 180 degree. Here the angle will be between 180 degree to 270 degree. Lastly, 270 degree to 360 degree. Okay. So again, ASTC rule. A, S, T, C. This is first quadrant, second quadrant, third quadrant, and here fourth quadrant. Now, fine. And I erase this and let us try to get the value of this. Make a note of that. Okay, dear students, now let us take this problem. So I am taking the problem here. So cos inverse of 7 pi by 6. So this is going with the same logic. No, we had fog and guff in relation and functions. So f inverse of f of x is equal to x type it is. So since I have got f here, I want the same invertible function. Since I have got cos, I want cos inverse itself. So surely We are not going to go with order. It will be even only. Only then cos will remain cos to get rid of this. Correct now? Now you see cos inverse. Now how to go about? First, check whether this is lying in that domain of ITF. Today we discussed the table we discussed. So first see 7 pi by 6. What is pi by 6? 30 degree. What is 7 to 30? 210 degree. Is this lying between closed interval 0 to pi? No. 210 degrees more than 0 to 180 degree. So I have to first make sure this angle should come back to this. That's why a right angle concept is used. Now how to do this? Very simple. See carefully. Write down cosine as it is. Always take down acute angle from this. Pi by 6 is the acute. See, carefully understand. Pi is 180 degree. Even if you divide by 2, no, 90 degree it is. So it means whenever the division of pi is starting from 2, no, solely that value will be less than 90 degree. Okay. So pi by 6 we have taken. Now write pi here. Now you have to do manipulation. Either you add, subtract, such a way that you should get back the question. Only then I can add equal sign. So if I subtract, LCM is 6. 6 pi minus pi will be 5 pi by 6. But I have 7 pi by 6. So I have to add. Now LCM is 6. 6 pi plus pi is 7 pi by 6. And this pi plus theta, nothing but more than 180, but less than 270, lies in third quadrant. In third quadrant, tan and cot are positive, remaining 4 are negative. So what I'm going to get here, we have got cos, but what we have here in third quadrant, tan and cot are positive, cos is negative. Write cos properly here. Cos is negative, so minus of cos, the acute angle. Now this is of the form cos inverse of negative value, which is pi minus cos inverse x. So in place of this x, we have this entire minus get balance. So by using this formula, pi minus cos inverse of x. What is x? Cos of pi by 6. Now see carefully, pi by 6 is what? 30 degree. And 30 degree lies between 0 to 180 degree. Okay. So pi minus, this is going with the invertible concept. For this particular interval, cosine is bijective function. So I can apply this, that f inverse of f of x will be x itself. So we have here, this is f inverse, this is f, and this is x. So I'll get pi by 6. Now take the LCM. Then nothing, it means 1. LCM of 1 and 6 is what? 6. Okay, reason is this. 6 is LCM. 6 by 1 is 6. So 6 pi minus 6 by 6 is 1. 1 into pi is pi. So answer is 5 pi by 6. This will be the value. I hope things are clear. Okay. So first PUC was required for this. Make a note. Okay. Dear students, on this I have given the assignment and I have given the numbering same as the NCERT. Make sure try to solve those problems. Okay. Yes, dear students, let us move on to the next problem. This is from model question paper number 1. Part C. As you know, it's a 3-marker question. So surely from this chapter you can see 1 question, 2 question 1, and then 3. 3 plus 2 plus 1, 6. So you can just say 5 plus marks assured. Okay. Now, see, since we have tan inverse here, we have written in simplest form, and that's what, no, I took this one before calculus. We can get the question same like this, and they may ask to find the derivative. So in place of differentiating directly, we have to simplify. That will be easier. Now here we have tan inverse. Since we have tan inverse here, this entire term should be tan. Only then you can get rid of tan inverse, I mean to say. So for that, in trigonometry, we have got a formula: secant square theta minus tan square theta is equal to 1. Among all the 3, sin square plus cos square and cosecant square minus cot square is equal to 1. Among the 3, why I am taking only this? Because I got tan inverse, so I want to bring tan. Now here it is 1 plus variable square. So if I transpose, we get secant square theta is equal to 1 plus tan square theta. So I will take this as equation number 1. See carefully, exactly in place of x, what do we have? tan, square get balanced. Still, if I take the square root of this, secant theta is equal to root of 1 plus tan square theta. It is exactly matching. 1, 1, root, and here tan square. So I can say put x is equal to tan theta. As soon as substitute tan theta value in equation number 1, this will become tan inverse of root of 1 plus, in place of x, tan theta, so tan, and here we have square, so square theta minus 1, okay, whole divided by tan theta. Now see carefully from here. What is from here? Root of 1 plus tan square theta from equation number 2. This entire term will be what? Secant theta. So tan inverse of, this will be secant theta minus 1 divided by tan theta. Don't forget, since you have tan inverse, this entire should be what? Tan in terms of tan. But we have secant and tan. Simplify. Whenever stuck in trigonometry, go back to basic. Which is the two basic trigonometric function, sine and cos. So let us go for that. So here we have tan inverse of, what is secant? It is 1 by cos minus 1. Okay. Whole divided by, what is tan in terms of sine and cos? Sine by cos theta. Now here is a fraction. You can see there's nothing. It means I can say 1. LCM I have to take because minus sign is a fraction there. So let us enlarge the bracket before we proceed. Yes. Now tan inverse of LCM of cos and 1 will be cos. Cos by cos will be 1. 1 into 1 in numerator will be 1 minus. Cos by 1 will be cos. 1 into cos will be cos. Divided by sine by cos. Now from here, see carefully, some simplification can be done. Cosine will get cancelled here. So remaining is what? Tan inverse of 1 minus cos in the numerator. Coming to denominator, we have got sine. Now comes multiple angle formula. Remember this formula. What is 1 minus cos theta? It is 2 times of sine square theta by 2. And what is sine theta? Again, submultiple angle formula. 2 times of sine theta by 2 into cos theta by 2. So we are going to have tan inverse of, coming to the numerator, 1 minus cos is this. So 2 times of sine square theta by 2. And sine theta from here, it is 2 times of sine theta by 2 into cos theta by 2. Some of the terms will get cancelled again. So see carefully, very clearly, 2.5 will get cancelled, 1 sine will get cancelled. So remaining will be what? Tan inverse of sine theta by 2 divided by cos theta by 2. What is sine by cos? Tan. So ultimately what we wanted, we have got. See, you have got tan inverse, so you wanted tan. I lost it, is getting cancelled. No, tan is taking domain to range, and tan inverse taking range to domain. So it's like this. See carefully. This tan will take the domain angle to number, and tan inverse will bring it back. Invertible function concept it is. Don't say it will get cancelled. They are not reciprocal of each other. So what I will get? Theta by 2. Nothing but half into theta. What is theta from here? Whatever we have taken the substitution. Let us write down again that one here. We have got x is equal to tan theta. Since I want only theta, take tan inverse both the sides. So I'll get theta is equal to tan inverse x. So half as it is, in place of theta, that is this theta, it is tan inverse x. This is the simplified version of the given question. Let I again comment here. What has happened here? We have taken tan inverse both the sides. When I take tan inverse both the sides, just see what happens. Let I write in more space. Space is less. Let I write again. X is equal to tan theta it was. So when I take tan inverse both the side, tan inverse x is equal to tan inverse of tan theta. Correct now? Tan theta. So this tan inverse x as it is, tan and tan inverse, no, it's not getting cancelled. This logic, tan will take angle to range and tan inverse will take, I mean to say range to, I repeat again, tan will take angle to number and tan inverse will take number to angle back. So we are coming back. So again it will be theta itself here. Okay, that's what tan inverse is equal to theta, nothing but theta is equal to tan inverse. So in place of theta we have put tan inverse with the half as it is. Okay, so this is a 3-marker question. Make a note of this. Here you can also think of an assignment that if you want to simplify, this is from NCERT, what will be tan inverse of root of 1 minus cos x divided by 1 plus cos x. No need to do any substitution the way we have did because here trigonometry was not there, but here it is already there. 1 minus cos, I have given the formula. Similarly for this, 1 plus cos theta will be 2 times of cos square theta by 2. So you can put 1 minus cos formula here and 1 plus cos here. But since we have theta, so it is theta here. But here it is x, put as x and then get the answer. It's an NCERT exercise problem. Okay. So this we can take as an assignment. Kindly make a note of this. Yes, students, now let us move on to model question paper number 2. Model question paper number 1 we have finished completely. Now only 2 and 3 markers are pending in both the model papers. Question says from part B, it's a 2-marker question. Prove that this sine inverse of this is equal to this part under this condition. Coming to the solution of this, see, when you want to solve the problem of the kind, prove that the one which is complicated, that we are going to solve to simplest form. So coming to left and right, which is complicated, this is a bit big expression. So I will consider the left hand side, that is sine inverse of 2x root of 1 minus x square. Now, since I have sine inverse and I want sine inverse here, I will be taking a substitution. Put x is equal to sine theta. How I came to know? Here sine inverse is there and one more is here also sine inverse is there. So put x is equal to sine theta. So if I take this as equation number 1 and this as 2, put in equation number 1. So my equation number 1, the left hand side will be sine inverse of wherever we have x, put as x is equal to sine theta. So 2 sine theta root of 1 minus sine square theta. What is root of 1 minus sine square theta? That is what? Cos theta. So here we are going to have sine inverse of 2 sine theta as it is. And this entire thing is from here cos theta. Now recall multiple angle formula of first PUC. What is 2 sine x into cos x? It is sine 2x. You have learnt like this. Sine 2x is equal to 2 sine x into cos x. But we should memorize both the side. It is like a plus b whole square formula also you should know. The expansion. And also a square plus 2ab plus b square is what? A plus b the whole square. Both the ways we should know. Okay. So we are just going from right to left. So since I have got x here, it is x. Okay. And angle is x, it is double of that. Here the angle is theta, theta. So it will be double of that. So sine inverse of sine of 2 theta. Now this is f, this is f inverse. Both will get removed. Answer will be 2 theta. But what is theta? Come back here. What is the substitution taken? X is equal to sine theta. So I want only theta. Take sine inverse both the sides. So I'll get sine inverse of x is equal to theta. From equation number 3, I can write this theta as what? Sine inverse x. How I got? From equation number 3. And this is what they asked. Is equal to right hand side and hence proved. As an assignment, you can think of solving the assignment problem. Prove that sine inverse of 2x root of 1 minus x square is equal to 2 times of cos inverse x. I am not given any condition. I think the condition is this: 1 by root 2 less or equal to x less or equal to 1. This condition is given because you don't forget, trigonometric is not bijective on whole. It is in restricted area. So under this restriction only, it will behave okay, as ITF. So surely what will be your substitution? Since you have got cosine in the right hand side, put x is equal to cos theta. Everything will remain same. Here you get cos, here you will get here you will get cos, then cos, but this will give you sine, and ultimately in place of theta it will be cos inverse x. Okay, hope so you will solve the assignment problem. This is the assignment from NCERT textbook. Okay, make a note. Dear students, let us move on to the next problem of 3 markers from the same model paper. There are many ways to do, but let us go for the one which can give the answer faster. See, you have to prove this left hand side is equal to right hand side. So since left hand side is having 2 terms compared to right hand side, we can go ahead with left hand side. Coming to the solution, let us consider the left hand side, which is cos inverse of 4 by 5 plus cos inverse of 12 by 13. I will take this as equation number 1. Now let us take this cos inverse of 4 by 5 as some angle x. This will imply if I take cosine on both the side, I will get 4 by 5 is equal to cos x. I don't think there's a problem here. Similarly, this one, let us assume that cos inverse of 12 by 13 is some angle y, and taking cos on both the side, because I got cos inverse, to remove that I will take cos on both the side. We get 12 by 13 is equal to cos y. Now let us take up a right angle triangle. Y, if I know one trigonometric function, I can find remaining 5. So I am taking a right angle triangle. Here also one right angle triangle. But before we solve this, let us try to understand why we need any other trigonometric function. Let us compute some of the things here. See how to proceed. Listen, this is my equation number 2 and this is my equation number 3. I am going to just put 2 and 3. Okay, just see carefully. This is my x, this is my y, correct? No, this entire thing is x, this is what? Y. So it is x. So I'm going to consider what? This term, which is x, we have taken, and then this term which we have taken as y, and between the both we have plus. Okay, so again this is what? X, and this is what? Y. Between them plus. If it was minus, I'll take minus. Now see what you want to prove. Cos inverse you want. So you will start the problem with cos. Let us suppose you had here tan inverse. Start the problem with tan. Here if you had sine inverse, start with the problem with the sine. Again, plus or minus depends on the question itself. Now what is cos of x plus y? Recall. Cos of x plus y is cos x cos y minus sine x sine y. So cos x, yeah, the cos x value is here. Cos y, the value is here. But I don't know what is sine x and sine y. That's the reason right angle triangle is taken. Now since here the angle is x, we will take the angle to be x. What is cosine definition? Adjacent by hypotenuse. This is adjacent and this is the hypotenuse, which is always opposite to 90 degree. By using Pythagoras theorem, surely this is what? 3. 3, 4, 5 is a Pythagoras triplet. So from here, what is sine x? Opposite by hypotenuse, 3 by 5. Next, cosine. Again, the angle is here, y. What's the definition? Adjacent by hypotenuse. Adjacent is here, hypotenuse is here. Again, opposite to 90 degree. And here it will be 5. How? 5, 12 and 13 forms a Pythagoras triplet. Otherwise, you can use Pythagoras theorem. For example, let us solve at least for this. So here, this was not known, correct? No. So, what Pythagoras theorem says, in the right angle triangle, square on the hypotenuse is equal to sum of the square of remaining 2 sides. So AC square is equal to AB square plus BC square. What is AC square? AC value is 13, so 13 square. AB we don't know. What about BC? 12 with a square. So this will be 169 is equal to AB square. Then 12 square is 144. Transfer the other side, what you will get? AB square is equal to 169 minus 144. Or I will get AB square, let's complete it here. AB square is equal to 25 because 169 minus 144 is 65. and AB value is only plus 5, then cannot be negative. So 5 I have taken. Okay, that's how you can solve this also. Now from here, since I want sine y, okay, what is sine y from here? Now sine y is what? We came to the value here, opposite by hypotenuse, 5 by 12. So this value and this value, both I can substitute. This is 3. Okay. So what is cos x value? 4 by 5. What is cos y value? 12 by 13. What is sin x value? 3 by 5. And what is sin y value? 5 by 12. Is it 5 by 12? Sorry, here. So, what is this? Opposite by hypotenuse. So 5 by 13. 5 by 13. Yes. Now let us simplify. What is the LCM of? Okay. First is multiply. 4 into 12 will be 48. 5 into 13 will be 65. 3 into 5 will be 15. Then again 65. LCM of 65. 65 is what? 65. 65 by 65 is 1. 1 into 48 is 48. 65 by 65 is 1. 1 into 15 is 15. How much is this? If I subtract, we are going to get 33 is equal to 65. Left hand side is what? Cos of x plus y. Now, you see, you got, now here, I want cos inverse. So take cos inverse both the sides. So we'll get, take cos inverse on both the side. So we'll get x plus y is equal to cos inverse of 33 by 65. But what is x from equation number 1? Cos inverse of 4 by 5 plus what is y? Cos inverse of 12 by 3, which is equal to cos inverse of 33 by 65. That's what they have asked. Make a note. Yes, dear students, we have come to the last problem of this model question paper number 3. And last chapter, means last question for this chapter ITF. Question says write this in simplest form under this interval. Coming to the solution of this, see carefully, have tan inverse. Let us copy what is given. We have been given tan inverse of cos x minus sin x divided by cos x plus sin x. See, since you have tan inverse, this entire should be what? Tan. Nothing to substitute here because already trigonometric functions are present. Now, recall first PUC compound angle formulas. Tan of x minus y. What is this? This formula expansion is tan x minus tan y whole divided by 1 plus tan x tan y. We are going to use this formula right to left. Now here we have 1. But in place of that we have cos. We can see minus is getting balanced, plus is also getting balanced. So here we are going to divide both numerator and denominator by cos x. How I came to know that? Because here I want 1. Here I have got 1. So in place of 1 we have cos. So divide by cos both numerator and denominator. Then we are going to have tan inverse of cos x is there here, divided by again cos x, then minus sin x divided by cos x whole divided by again cos x divided by cos x plus sin x whole divided by cos x. So I have divided both numerator and denominator by cos x. Now see carefully, this cos by cos will get cancelled, get 1. Here cos and cos will get cancelled, get 1. So let us write down the remaining part. See carefully, what do we have? Tan inverse of 1 minus, what is sin by cos? It is tan. whole divided by 1 plus sine by cos is tan. Now see carefully to apply right to left. Here you should have difference of tan, but here we have 1, there is no tan. But don't forget, we can write 1 as tan pi by 4, then minus tan x as it is. Here also I've got product of 2 tan, whatever is the numerator, same thing in denominator. So I can write this as 1 into tan. So 1 plus, what is 1 in terms of tan? Tan pi by 4 into tan x. So now let us compare. See, this right hand side is exactly matching with this. In place of x we have pi by 4. In place of y we have x. Okay, so now I'm going to substitute in this formula. So I'm going to use this formula, tan of x minus y it is. So first tan inverse as it is. Then what will you get? Tan of x minus y. What is x? Pi by 4 minus what? Y. In place of y, what do we have? X. Now both will get removed. Answer is pi by 4 minus x. When I say both will get removed, what's the meaning? Tan will take angle to number. Tan inverse will take number to angle. So we'll get back the same angles. Okay. So this is the simplest form of the given question. So the main reason to complete ITF before studying calculus was this. Let it be trigonometry or inverse trigonometric functions, it will be surely be present in calculus. And for example, when I want to differentiate this, in place of differentiating this and applying quotient rule, this is far better. Just apply difference rule and get the answer. Okay. So kindly make a note of this. Okay. Yeah. Dear students, with this, all the problems and the concept is done. Concept completely done and problems from model question paper, all the 3. And I've also made sure to give assignment. Make sure do the assignment, study well, write and practice. Don't be overconfident. Time is less. Okay. Give your 100%. Okay. All the very best. God bless you all. And kindly do like, share and subscribe to my YouTube channel, Math Universe with Dr. Naseer Ahmed. Thank you.